So, hello everybody. Thanks for being here. Thanks for having me. And first of all, thanks for Qubes OS, because that's such a great tool. Today I would like to share some experiences, how we try to use Qubes on our laptops in an IT department in the Stahl Holding Saar. Stahl Holding Saar, that's just the holding above Dillinger and Saarstahl, which are steel factories. IT is mostly located in the holding, that's where I work, and we are trying to use Qubes as our work laptops for the day-to-day tasks, and yeah, I want to share some experiences with it. So, we are just a small department. We care about data center infrastructure, like the servers, some part of the cabling, storage systems, and Linux systems also, the VMware infrastructure, such stuff. So we want to use Qubes, but actually, to be honest, at the moment, it's just two people, a very small pilot group. That's me and my colleague Dominic, who is also here in the audience right now. And why would we want to use Qubes? Why not just use the Microsoft laptops that are already provided in our company? Well, I don't have to explain why we don't want the Microsoft laptops, but why Qubes, why not a bare metal OS on it? So far, I just used a Linux install bare metal on my laptop, because we will have to use Teams and M365, which means our laptops, at least during work hours, will be connected to some cloud permanently, which is a dangerous thing. At least that's what we think. So how can we do this? We might put this on our bare metal Linux laptops, but I think Qubes is the better alternative, because it's great at doing the separation stuff. So we are still in the early phases of adoption. We are still just the small pilot group. So we did not isolate further than just putting out the cloud stuff and a work domain, a work app VM. We are still exploring what is useful to further separate. But what we already gained, thanks to the brilliant work of other people who wrote about it, who documented this, we have key paths separated in a vault domain and also the SSH keys in the vault domain, which is very nice because the master password for the key paths never hits the work domain, and even the decrypted states of the password database is invisible to the work domain where you do the everyday tasks. So the chance of this getting feed and migrating to some bad actor is very, very low. Thanks for that. And also, why would we want to use Qubes? Because it's open source. We get no false promises. This is not a rose garden either, so it's not that easy to adopt all the methods, the structures of it. It's a lot to take in, so we are still in the early phases, but still I think it's the best we could do. Qubes has some programming, design, and assumptions about the infrastructure. Infrastructure is not to be trusted. That's what Qubes OS developers try to follow. And DOM0 is, of course, because it's using the Zen hypervisor, DOM0 is the command center. But it's very well isolated. There is no IP, no internet protocol connectivity in it. So it's very hard to attack DOM0. So, and everybody else has to listen to the commands of DOM0. That's the design in Qubes. And as DOM0 is probably immune to compromise, or mostly immune to compromise, unless you will do it wrong, there's a chance that you can put your system back to a sane state, even if single VMs get compromised. In contrast, what we have in a corporate network is we have a huge list of things that we need to trust. And this is the trust in ticks, in quotes, because you can't really say they are trustworthy. It's just as in a trusted computing base, this is something you must use, and you can't just not use it. So you are exposed to every failure in these components, but you have to trust them, because this is the reality in a corporate network. And it's quite a list. Mobile device management, the backup systems have high privileges, so if anything happens to these backup servers, all of your IT is just lost. So that's a whole staff of things. So that's really contrary to what Qube's design is assuming, or under what assumptions Qube is developed. So, networking in Qubes. You have the internal structure of the communication between the single cubes. And to access the network, there's propagation up to this firewall, to this net, out of the physical network. And then there's the implicit assumption that beyond this net, maybe 1 or 2 hops away, is the internet. The internet means you have no private IP addresses, and you can reach everything there is on the registered official IP addresses in the network. Of course, we know there are things like internet blocks, bad things are happening, but basically that is the idea behind it. And also DNS. There's the assumption you connect to the network, maybe via DHCP, and you get a resolver address, and you can use that and get basically everything that there is in the official internet DNS. So, sorry for my artwork. This is a simplification of internal corporate networks. There is still the internet, but it's quite far away, topologically. And even the local network is separated into several subnets. And these are not directly connected. They are not 1 to several corporate firewalls administered by different people. And if you say, like, we connect with our laptops to the office network, and we say we need access to the remote access card, so we don't have to drive around to connect to some server and just to reboot it, then we have to tell them, so they give us an ACL entry that we can access this card. As long as the infrastructure is working, yes, that's fine. But, you know, that's a lot of infrastructure, and most of it is, sorry to say, not open source. And bad things happen. Updates break things. There's problems with the power sources. So there are times when you can't rely on firewalls and switches and stuff really working. So then you have to drive to the hardware and connect to a switch near or even directly to the system. And I very much like to be using the same system that I just use for everyday work when directly connecting to that part of the infrastructure. These slides are not addressed to you. I think you all know how this works. This is mostly for our internal people, that we also have to be able to access parts when bad things happen directly with these laptops. So, and back to you as the audience, as I said, we are still designing and thinking how to do it, but the most probable way is probably that we will have dedicated sysnet instances, so that when we directly connect to a hardware, then we don't want some browsing stuff perhaps having access to the network while we are just fixing things. So we will probably use dedicated sysnet instances, which means we will have dedicated application VMs to do SSH and perhaps browser interfaces on the remote access cards, just for these cases. So one more complication is that even to get inside our networks from A to B, perhaps you need an HTTP proxy. Some things are not directly reachable. And to further the complications, this needs authentication. And even worse, it needs Kerberos authentication. So, will this fit? That's the question. So, the young guy with the hammer, that's me, and as you can see, I liked to hammer at Qubes already at a very young age. We would prefer to be able to use Qubes without using real force, and not even break it, perhaps. So, as I said, there's limited connectivity. And the worst part is HTTP proxies with authentication. So, of course, then Unix is off the table. Okay, but it's a corporate network. What do we want with Unix inside it? Then proxy configuration. That's a bit of a hassle, especially when we go to disposable VMs, because we have to propagate the configuration and perhaps some authentication credentials into the dis VM, depending on whether or not we want them to have network access or not. That is really some area that needs more research, that needs more thinking on our part on what do we really want. And only if we know what we really want, then we can really start designing ways of using disposable VMs with network access. So another thing is IP addresses, because we address the internal corporate network, which uses private IP space. There is a chance of collision between the IP addresses that Qubes uses internally with the address ranges used in the corporate network. We have been very, very lucky that the reserved IP addresses that Qubes use, the 10.137 for the app VMs, 10.138 for the disposable VMs, and 10.139 for DNS services, were not used. That would have been a real showbreaker, but we were lucky. Still, I said, let's play fair and claim that address space from our IP address management folks, and they kept asking a lot of questions. Why do we need such a huge allocation? Can't we have this smaller? So that was a bit back and forth, and I'm really not sure if it's finally settled. They just stopped asking questions. As an explanation, I put up some routing tables. So let's say I want to access anything beyond sysnet, but it's in a reserved, in the private IP space. Then of course it starts in sysnet, which basically just has its own IP address. Everything in Qubes networking is based on host addresses. So Qubes uses the address space rather sparingly, which is great, but still there is a chance of collision. So next hop is our VPN app VM, network VM. At the moment, it's not in a VPN mode, so it passes the packets onto this firewall. To have a list that actually shows something, I fire all the app VMs that I have, plus one disposable VM, or the list would have been very, very short. So there are just a few IP addresses, and that is possibly the base for conflicts. And if any IP address I would have wanted to reach was one of these, I could not connect to them. So question would be, can we have that range configurable so that it doesn't really have to be 10.137, 10.138? For us, it works. but for other corporate networks that might be a problem. And can we perhaps shrink it? Is that even possible? Because it's bound to the VM ID, and VM IDs are allocated in sequence for app VMs and based on random numbers for disposable VMs. Is there something that needs to have that huge number space, like for restoring from backups or something? So that would be just one question. If we could have more flexibility in that area. Then another thing, we have our own certificate authorities. So we have to propagate these to at least the app VMs. And of course, there's more than one way to do it. And we are still thinking about choosing one way, which is hopefully also the best way. There's a difference between the templates. Fedora puts these, your private CAs, you put them in a directory which is owned by the template. In Debian, you put them usually under the user local directory, which belongs to the app VM. You can merge them inside the template VM, so the resulting file is in the directory space of the template VM. The app VM inherits this, but if the app VM would happen to run the update scripts themselves, they would lose the private CAs. And like I said, it's difficult. Do we want them in disposable VMs or not? We're still thinking about it. It's difficult. Then, this was actually the highlight of the talk. You remember, we don't want to use force, but in this point, I'm afraid we used a bit force and perhaps used a bit much. There are, as far as I know, 4 different update mechanisms. You have one for the template VMs, so the package updates inside an existing template. You have the template manager to download new templates or remove old ones. You have another mechanism to put updates into DOM0. And finally, there's the BIOS update manager. The first one already uses tiny proxy. Template VMs do not have IP connectivity, but it's propagated via a Qubes RPC call. And by default, I can't remember sysnet or sysfirewall will start the tiny proxy instance. So there is, for that mechanism, there is already some support for upstream proxies, for proxies at all. And what I do then is I just add an upstream statement into the configuration. But also I have to allow list these destinations that are used. The destination list for Debian is quite small, that's easy. The destination list for Fedora is huge. So I just put in, I just allow listed a few of them, and sometimes an update will not work because it tries some destinations and none of them will be reachable, and then I have to do it again. So there are still 3 mechanisms that don't have upstream proxy support at all. So I hacked them into it. And yes, it's in DOM0. I hack around in DOM0. Shouldn't do that, I know. But that's the method I came up with. It's a very complicated script because it has to work for 4 different mechanisms. And it does actually patching. Some of it is a patch statement, some of it is an SED script, where I forced into the code from DOM0 to apply an upstream proxy. And it already broke once, because after one DOM0 update, the scripts that I hacked in have changed. So the patches did not apply anymore. So this is ugly, perhaps even dangerous. So don't try this at home. And I really hope that it will be possible one day that Qubes support it out of the box, that you can have upstream support for all the update mechanisms. So, final slide. What I would wish for. Maybe I ask for a bit much, but yes, it's close to Christmas, so I started my little wish list. The laptops we use. These are the standard laptops that we use in the holding. So these are just plain Dell laptops which have no support for S3. And S3 is the standard suspend mechanism, or it was for a long, long time. And now they only support the modern standby. That's fine with Windows, that's fine with Ubuntu or Arch on bare metal, but it does not really work with Qubes, or perhaps it's just Zen that doesn't handle it well. So if I put my laptop on suspend, it uses almost as much energy as when it is just running. So when I take my laptop home and I put it in the bag, I leave the bag open so that the machine doesn't die from heat. I was lucky that it wasn't really heavily raining while doing this, which would be probably not healthy for the laptop. So that would be high on my wish list, to be able to take the state of the open windows and stuff, to be able to take them home or to take them from home to work without overheating and without having to reboot and rebuild all my working infrastructure. Another point is we do video conferencing a lot, and at the moment we use Jitsi inside a browser in the work VM. I would prefer not to, but that's how I get to share screen content from the work domain. I know there is the Qubes Video Companion, and I tried it, but it has limitations. It shows up as a video camera. So I can switch to another camera, so I can select if other people see me or if they see my screen content. And also I would love to put the camera out of the work VM and even out of the conferencing system. And I would use Qubes Video Companion for that. But then I need two Qubes Video Companion instances, and that doesn't work. It just always says, oh no, there's already one instance running. Another one, which is really probably a large wish, we already have the vaulting for KeyPass and for SSH keys, but we use Kerberos a lot. And with KeyPass, you still expose the single passwords to, let's say, the work VM. And in Kerberos, these are really, really powerful passwords, and they have the resulting ticket also has a very long time span that it's valid for. And I think it would really improve the system if we could proxy that away, if we could vault it away. That type of vault would need network access to reach the Kerberos servers, but perhaps it's possible to move the resulting TGTs from there to the work VM. Still, it's a long-lasting secret, but I would not have to enter this powerful password in the work VM. And well, there's even more to put into. Perhaps one could even adjust it that the service tickets that are finally granted would also be handled by a Kerberos VM. But probably you would need to adjust the client libraries for that, to add some kind of proxying support into the client libraries. So, thanks for your attention. That was my talk. And now to your questions.
We have 5 minutes for questions. One moment, please. You can start, yes.
So you mentioned the thing about disposables usage and configuring them. You can use named disposables and then configure each cube as the client to use that disposable template. So you can configure the named disposable to have the keys. So like you don't share the keys with multiple disposables, but only of descendants of the same disposable template.
Yeah, thanks for that point. Maybe we can talk about it later. We just started looking into disposable VMs, and probably we just missed many opportunities. So it's great if we could talk about that later. Your feedback is very, very welcome. Thank you.
Hello. I wanted to talk about the modern standby.
Yeah.
It doesn't work in Zen. Modern standby was designed and only really works with native operating systems. It depends heavily on AML in the ACP tables, being able to poke random bits of the hardware. So there's been questions about it for quite a long time, but we need to invent some kind of AML proxy because otherwise each of the VMs that had the device would need access to the main motherboard resources simply to put it into a low power state. So it is a very complicated problem, more so than most other bits we've got.
I thought so, because otherwise it would have already been implemented, I guess.
Yes.
To explain in a little bit more simple words, when a modern standby is used, the operating system turns the low power mode for the devices, but what in fact happens is that the device is actually disappearing from the system because its power is completely cut off in the CPU. So then, of course, can't handle that if this device was, for example, passed through to the virtual machine, right? So it basically breaks whole model of the virtualization in Qubes and in every system that uses actually Zen or any virtualized environment.
To be clear, it's not just Zen. It's
it's
anything that's not a complete normal Windows or a complete normal. Yes, thank you, Intel.
That's their policy to drop S3 and move towards the modern standby.
Yeah, I was very disappointed that Dell doesn't support S3 anymore.
Yeah, that's a problem. We have a person who tries to make it work, and he managed to make it work on 1 or 2 machines, I think. So it requires specific hardware and then a lot of time, basically. So. Yeah.
What about hibernation, actually? Because there was also the hibernation on the S4 state.
That's a different can of worms.
Yes. Yes. Yeah, but I have some different points here. Regarding the proxy, a lot of points you talked are with the proxy authentication. So for updates, you can actually configure it in the repository settings, the repo files for both the DOM0 update and the template updates. And
I cheated because I listed this in the proxy configuration of the upstream proxy to not enforce authentication for these targets.
Yeah.
So no, we don't have for template updates and the other update mechanism, there is no Kerberos authentication.
Yeah, but you can, I'm not sure about the authentication, but to use proxy for updates, you can configure it in the repo files. But regarding the authentication, have you considered using proxy with authentication that provides proxy to other proxies?
I'm not sure I fully grasp your proposal. You mean an RPC proxy for HTTP proxy?
I mean, so there is this tiny proxy thing, but you could possibly have a proxy that has authentication credentials, but on the other end expose just to selected VMs unauthenticated proxy, and it adds like authentication token on the way.
Yes, if you don't tell anybody. I've used that already. Because
which VM has access to this
in the work VM, I set up a Squid proxy, and that Squid proxy can use my Kerberos tickets. and I have a Firefox instance guarded away by FireJail inside the work VM. And that means it can't access these Kerberos tickets, but it can use this additional Squid instance as its upstream proxy, so it can access network from there. So yes, but I didn't really analyze it if it's possible to use that for DOM0 updates. The networking part is done, I think, mostly in SysNet.
SysNet and
Or
sysfirewall,
Firewall,
depending on the
yeah.
update VM. But you can change it like it's a setting.
And yeah, well, nice thought. I will need more thinking, like with most things that need more thinking and designing. Yeah, but thanks, yeah.
Last minute for questions.
I have one short, maybe. Did you run? Did you run into any software compatibility issue with Qubes?
So far, not.
Okay.
Because we don't have Windows running.
Okay.
So there's M365 on Linux. It's convoluted, but it's possible.
Simon, your question, please.
Okay, I think most have been asked by Mark. For the S0X, there is some experimental flag which we got working on some system in general. As described, it's a problematic, but for some system, maybe you can get it worked. That might be worth trying. Yeah, I think the other points were already addressed.
Okay. Yeah, then, thank you.
Diplo, your question.
Yeah, maybe I can ask.
Thank you very much.
Just one comment. So thank you very much for the feedback from the industry. That's very important for adoption of Qubes OS. So great presentation. I guess we have to build the pressure on the procurement, where we essentially standing that either Qubes OS certified, of course, assuming that the devices will fulfill your requirements. That's the thing, or maybe call current provider and tell them why you don't deliver something that works with Qubes. So they get the signal that doesn't matter if there will be enough people calling them, they will listen.
Yeah, in our department, I think it will finally amount to 8, perhaps 10 Qubes laptops compared to, I think it's in the thousands already of the laptops used. So this is a large volume procurement, which means it gets a good price. If we ask for a Qubes certified laptops, that 4 or 5 times the price of this. I very much would love one, but I don't think this will be possible. And pressuring Dell with maybe 10 systems, I'm afraid this will not work.
Last question.
So, 2 quick comments. Have you tried packaging your corporate CA in a standard Linux way?
Not yet.
Because that would probably help you. And also, if you have a CI/CD pipeline in your corporate environment, that's probably where you want to put a proxy to all the updates in Fedora. Yeah?
You mean mirroring, doing a local mirror of
Something
Fedora?
like
Okay.
Artifactory or something like that, like GitLab, that points to all the Fedora repos you want to access to.
Okay.
Then you can configure that locally in whichever Qubes you like, right?
Yeah. Yeah. Good idea. Thank you.